Now let us discuss solid modeling representation schemes in detail. Constructive solid geometry. The simplest solid objects used for representation are called primitives. Typically, they are the objects of simple shape. The set of allowable primitives is limited by each software package. So, the constructive solid geometry is a technique used in solid modeling which allows a modeler to create a complex surface of object by using Boolean operators to combine the objects. Often, CSG presents a model or surface that are visually complex, but is actually little more than cleverly combined or decombined objects. A CSG defines a model in terms of combining basic and generated solid shapes. The objects are represented as a combination of simpler solid objects called primitives. The primitives are such as cube, cylinder, cone, torus, surface, etc. Copies or instances of these primitive shapes are created and positioned. A complete solid model is constructed by combining these instances using specific set of logic operations called Boolean operations. In constructive solid geometry, we use some basic primitive solids to represent a solid geometric model. Among them, we have 7 basic primitives. They are cube, rectangular prism, triangular prism, sphere, cone, torus, and cylinder. These are the basic primitive solids which are either used as a single entity or in a combined form to get the required solid model. Now let us see solid modeling example using a constructive solid geometry. Here, this is the solid model that is intended to be created. Now here we take two basic primitives, that is a cylinder as well as a rectangular prism. Now using the union operator, this model is being created. Next, taking another cylinder primitive of a different size, the subtraction or cut option is applied with this solid model and we get this model. Now to this model again we take a rectangular prism similar to this one of different size and we apply again the Boolean operator cut or subtraction. Thus we get finally this solid model. So here if you see, different Boolean operators are being used in different stages of the model development to finally get this model. And this is one approach. There are different approaches based on the designer views as well as the software compatibility. So constructive solid geometry, in CSG, objects can be represented by binary trees where leaves represent the primitives and nodes represent the operations. So here in constructive solid geometry, we can call the constructive solid geometry as an inverted binary tree. Here we can see what do you mean by the binary tree. That means this operation is obtained by the union of these two basic primitives, and this object is obtained by the union of these two objects, and this object is obtained by the union of these two objects. Now in this figure we can see the nodes are labeled for intersection, for union, as well as different. So the leaves represent the primitives, that means the leaves, these primitives are the leaves, and the nodes represent the operation. So what does the set theory shows? The set theory shows the three basic operations that is being used in CSG. The first one is A union B. That means this A primitive as well as the B primitive is totally considered. Now the second operator is difference. In difference, A minus B. So A minus B, if it's A minus B means this portion would be here. But for showing this as example, they have taken B minus A. That means the B is being subtracted with A. That means this much portion is being cut, and we get this half moon as the difference, the violet color. So that is the second operator. And third operator we commonly use is an intersection, that is A primitive as well as B primitive. When they intersect, this portion, this convex portion, is the intersection. So these are the basic three Boolean operators that we use to construct a solid model using constructive solid geometry. Making it more clear, Boolean operators, the first one is union, the sum of all points in each two defined sets, that is the logical OR, also referred to as add, combine, join, merge. Let us see, this is the A primitive and this is the B primitive. So A union B gives this solid model. The second Boolean operator is the difference. The points in a source set minus the points common to a second set. That means this is the basic primitive A and this one is the second basic primitive B. Now A minus B means from the A, the B is being subtracted and we get this object. So this is the second basic primitive difference. In the Boolean operation intersection, those points common to each of two defined sets, that is a logical AND, the set must share a common volume, also referred to as common. Let us see the primitive A and primitive B. When it goes for an A intersection B, what it has, the set which has the common volume is being considered. So this common portion which has a common, shares a common volume, is taken into consideration. So in such cases wherein we require some kind of an intersection part or an intersected part to be constructed, we can use the Boolean operator intersection in CSG. Making it more clear, this object A union B, the two basic primitives, they are applied with union. Now subtracted is B minus A. B minus A, that gives this one. Now A minus B, this is A and minus B, so you get this object. And A intersection B, that is this hidden portion, hidden line represented portion. So this is making you more clear about the Boolean with the various Boolean operators that is being used in a constructive solid geometry for creating a solid model. Constructive solid geometry, advantages and disadvantages. First, let us see the advantages. It is easy to construct a solid model with minimum step. CSG modeling techniques lead to a concise database. Complete history of model is retained and can be altered at any point. Can be converted to corresponding boundary representation. CSG models are always valid since they are built from solid elements. CSG models are complete and unambiguous. Now the disadvantages. Only Boolean operations are allowed in the modeling process. With Boolean operation alone, the range of shape to be modeled is severely restricted. So, it is not possible to construct an unusual shape. It requires a great deal of computation to derive the information on the boundary, faces, and edges, which is important for the interactive display or manipulation of solid. Even then, constructive solid geometry is a widely used solid modeling technique nowadays.